Okay, in this video, we're going to be talking about binomial experiments or binomial probability. And I do want to point out the word binomial. It is very similar to binomial expansion, which the previous video talked about. So a binomial experiment, we know that the prefix bi means two, such as when we're foiling out like x plus 3, it had two terms. A binomial experiment is an experiment. A binomial experiment consists of n independent trials in which there are two outcomes, and that's why we call it a binomial experiment. There's going to be either a success or a fail. Probably the best example is going to be flipping a coin, to where we want to know, okay, about how many times it would land on heads out of 5 flips, or how many times it would land on tails out of 6 flips, or whatever. In those cases, your success, if we want to know how many times it's going to land on its heads, that'd be a success. The number of times it lands on tails would be a failure. The probability of success P is the same in every trial. And we know that with flipping a coin, that every time we flip it, it's the same probability it's going to land on heads. The probability of Q in every trial must be the same, to where Q would be a failure. The probability of success in each of these trials would be P. The probability of success is P, to where the probability, again, we said it right here. The probability of failure. Okay, now let's think about this. We're going to call it Q, or since you've got one thing happening or the other, like with flipping a coin, it's going to be either a heads or a tails. We're going to say that Q is going to be the same thing as 1 minus P, because we know that 100% that these two, either these successes and failures, since they're complements, there's the word we're looking for. Since these two events are going to be complements, either success or fail. If one of the probabilities is 30%, the other one's going to be 70%. If one of them's 20, the other one's going to be 80, because that's the only two things that can happen. So the two probabilities have to add up to 100%. So that's the reason I can say that if the probability of success is a P, then the probability of the failure is going to be 1 minus P. Okay, I want to give you an example of this. Well, let's go over these examples first, and then I want to go over and I want to give you a real example before we go into the whys behind all this. An example of an experiment: randomly selecting a month 30 times. Where maybe if this is our experiment, we're wanting to know the chances of selecting a January so many times. But again, the experiment is we're going to randomly select a month 30 times. And let's say that if the month that is selected is January, then we call that a success. If it's not January, then it's a fail. So therefore, this is a binomial experiment because you have a success and you have a fail. There's no in between. There's nothing else, to where the chances that we're going to select January is 1 out of 12. The chances we're not going to pick January would be 11 out of 12. So we can see here this is a binomial experiment, because if you were to add these two together, that's the only two things that can happen. Or maybe we're going to randomly select a card 100 times, to where we're going to say if we pick a heart, that's a success. If we don't pick a heart, if we pick a spade, or if we pick a club or a diamond, then that's a fail. So therefore, the probability that you're going to have success there would be a 1 in 4. The probability that we're going to have a fail would be a 3 in 4. And we can see again, this is a binomial experiment, because if you were to add those two probabilities together, that's equal to 100% or 1. That's the only two things that can happen. So let me come over here and let me share with you an experiment. And I want to show you why this is true before we actually go into working some of these problems. Let's say that we're going to roll a dice. Let me get on my pencil here. That's good enough. We're going to roll a dice. And let's say that as we roll this thing, I want to know what's the chances, what's the probability if we roll it 4 times. what's the chances of getting a 6? Let's say 3 times. If we roll a dice 4 times, what's the chances that we're going to roll a 6? Now let's talk about the probability of rolling a 6. That's a 1 in 6 chance because there's 6 sides to a dice, and that's going to be the probability of success. So what would be a failure then? A failure would be rolling a 1, rolling a 2, rolling a 3, rolling anything else except for a 6. Let me get rid of these dots down here. So therefore, the probability of failure, we have a 5 in 6 chance that we're going to fail in this experiment. So if we're going to roll it 4 times, what's the probability that we're going to get a 6 exactly 3 times? Which we already know that's not going to be very likely. But let's go back and let's talk about that whole counting principle and all that stuff again. What's the chances that if we roll 4 dice that we're going to get a 6, a 6, a 6, and then something else besides a 6? Well, the chances here of getting a 6 would be a 1 in 6 chance. The chance of here of getting another 6 would be the same, and then the same. And then the 4th time, the chances of rolling something different would be a 5 out of 6. But wait a minute. That's not the only way that we can roll 3 6s. Do you understand that we could possibly roll a 6 here? We could roll a 6 here. We could roll something different here and then roll a 6 on our last roll. Or we could roll a 6 here and a 6 here and here and then roll something different here. Or there's one last opportunity to do this. We could roll something different here and then roll the 6s here. Now, I do want to show you that no matter which scenario that we go through, the chances of this happening are 5 out of 6 times 6 times 6 times 6. That'll be 6 to the 4th power, which is 12,000 or 1,296. Or this would be 5 out of 1,296, or this would be 5 out of 1,296. They're all for the same probabilities, even though they're in different orders. They're all 1,616, 316, and 156, or 3 successes and 1 failure. However, there are 4 different ways that this could happen. I want to remind you that we call this a combination. This is all the different ways to where this could have happened in this scenario. We could to where these 1-6, the order doesn't matter for the 1-6, but it does matter where we put that 5-6. So let's go back now. We could actually have added all these together, and we got 20 out of 1,296, which would have been the answer. And we could reduce that and turn that into a percentage. But let's go back, and I want to show you now. Okay, the binomial probability formula. If a binomial experiment has n trials, which means we're going to do something so many times, n times, in which P is the probability of success and Q is the probability of failure. Like in the last experiment, our trials was 4 times. We was going to roll a dice 4 times. Our success was rolling a 6. Our failure was rolling anything that wasn't a 6. Our probability for success was 1/6. Our failures, our probability of failure was 5 out of 6. The probability of failure, then the binomial probability that there would be exactly R successes would be the following formula. We start out with a combination. The combinations of N choose R. And again, the reason we throw in a combination is that's all the different ways that this could play out. Like in the last one, there was 4 different ways that they could happen. The reason why was we had 4 trials, and we had R successes that there would be, or excuse me, 4 choose 3. So that was 4 different ways that could happen. So we're going to do the combinations of N choose R, to where R, again, is the number of successes, and P is the probability of each of those, to where now we have P to the R power, to where P is the probability of success. So we're going to have success 3 times, 4 times, however, times Q, which is the number of failures, raised to the n minus R. And this formula here is the exact same thing we did on that last problem. So don't let that mix you up. Okay, so let's try to use this formula on this next problem. So Mark tosses a coin 25 times. Now it'd be a little bit harder because now we'd have to draw out 25 slots. What's the probability that he gets gets ahead exactly 7 times? So again, I want you to think of it though. Think about it if we had like 25 blanks drawn out. We want to know what's the probability, and I know that's not 25, but just imagine there's 25 of them. Imagine, okay, we want to get heads 7 times, so maybe the first 7 is 1/2, and then the last 18 would be tails. Or the first 6 was heads, and then we roll the tails, and then the last ones. Well, let's throw out all the what ifs, and let's just say that's going to happen exactly. Let's see. How many different ways could we have this success fail? Would be the combinations of 25, choose, and then R again would be how many successes, and we want to know a success. Here's what a success looks like. It's a heads. So what's the chances of getting a heads 7 times? So out of those 25 rolls, we want 7 heads. So now we're going to multiply that by the probability of a success, which is 1/2. That's going to happen 7 times. And the failure, oddly enough, this has the same probability, and that's going to happen the other 18 times. So again, this is the probability of success. This is the probability of failure. So we want success to happen 7 times, failure to happen 18 times. And then that's going to be the probability of that happening. And then this is all the different ways that this could play out. You could have, like I said, you could have 4 successes and then failures, and then 2 more successes, and then some more failures, and then 1 more success, and then the rest of them failure. There's several different ways that we could rearrange that. And this is taking care of the whole rearranging. And as I type that in my calculator, I get a value of about 0.0143. So we're going to move that over twice, and that's going to be about 1.4% chance of happening. So not very likely. So if you toss a coin 25 times, it's not very likely that exactly 7 times you're going to get ahead. The next problem says the spinner below is spun 10 times. So we start out with the combinations. We're going to spin it 10 times. We want to know the probability that it lands on red exactly 6 times. So the combinations of 10, choose 6 times. Let's talk about the successes, and then let's talk about the failures. Red is 1, 2 of the 6, 2 of the 6 slots, so that's going to be a 1/3 chance that it's going to land on heads, and we wanted it to do that 6 times. So there's your successes. So that means that the failures, and again, those always have to add up to 1, 1/3, and 2/3, because it is a binomial experiment. So we want it to land on a success 6 times and a failure the other 4 times. And we type that into our calculator. Let me do that. And I get about a 5.69% chance of this happening. Next problem. Kate took a multiple choice test with 4 choices for each question. If she guessed the last 5 questions, so there's 5 different questions she's guessing on, what is the probability she gets exactly 3 right? So we start out with our combinations. Out of those 5, we're choosing 3 to get right. Okay, the combinations of 5, choose 3. Our successes will look like this, and then we'll have our failures. So what's the probability she gets 3 questions correct? The chances of getting a question correct, it's multiple choice, so a 1/4 chance of getting it correct. And so this is our successes, so we want to get 3 right. And the other ones, we want to know what's the chances that we got them wrong. So 3 successes, 2 failures. The probability of success, again, is 1/4. We want that to happen 3 times. 3/4, we want that to happen twice. Here's all the different ways that we can organize it. We type that into our calculator, and we get about an 8.79% chance of this happening. The next one says Chad randomly chooses a card from a standard deck of 30. Chad randomly chooses a card from a standard deck 30 times. What is the probability that he gets a diamond exactly 4 times? So all the different ways this can happen. He made 30 times. What's the different ways that he can choose a diamond 4 times? So that's the combinations of 30, choose 4. We do our successes, and then we're going to multiply times our failures. Our success, what's the probability of getting a diamond 4 times? So the probability of getting a diamond is a 1 in 4 chance. We want that to happen 4 times. Let's see, what is the probability that he gets a diamond exactly 4 times? So a failure would be a 3 in 4 chance, and since he's only Chad randomly chooses a card from a standard deck 30 times, what is the probability that he'll get a diamond exactly 4 times out of the 30? So that means we want a failure the other 26 times. So again, I just need you to understand this is all the different ways, this is all the different ways it can happen. This is the probability of success here, and this is all the probability of all the failures. We multiply all that together. Let me see what I get. I get about a 6.04% chance, and that takes a little while to plug into the calculator. That's the reason I'm pausing the video to be able to type into the calculator, so it won't take so long. The next problem, there are 30 balls numbered 1 to 30 in a bag. One is randomly selected 12 times. What is the probability of getting a prime number exactly 5 times? So you're making 12 selections. So that'd be the combinations of 12, and you are wanting to know, we're going to choose 5. We want 5 of them to be primes. So that's all the different ways that we can choose those primes from our 12, all the different orders there. The successes, and then the failures. First off, we're going to have to spend a little bit of extra time here because the balls are numbered 1 to 30. The chances or the probability of success is going to be a little bit harder to calculate here because the success would be all the prime numbers. Now, I remind you that 1 is not a prime number, but 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, I believe, are all the prime numbers. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 prime numbers out of those 30, so 10 out of 30. The probability of success is a 1 in 3 chance, so therefore my failure probability will be a 2 in 3. We want the successes to happen 5 times, exactly 5 times, so that means my failure is going to happen 7 times. So therefore, there's how you set the problem up. Now type in your calculator, and you're going to get about a 19.08% chance of this happening. So nearly 20%, nearly 1 out of every 5 times it's going to happen. Number 6, the probability of customers at a store receiving a coupon printed on the receipt is 1 in 8. So therefore, I would say that that's probably going to be your success probability there. If 20 customers visit the store today, what is the probability exactly 3 of them receive coupons? So out of the 20, we're going to, all the different ways that 3 people can rearrange and receive the coupon. The probability of success is 1 in 8. And we want the success, well, let's go ahead and do the failure, which would be 7 out of 8. We want the success to happen 3 times. 3 of them receive the coupons. And therefore, the failure would then happen the other 17 times. That should always add up to the 20 times right here. We type that into our calculators, and you'll get about a 23.00% chance of that happening, nearly 1 in 4 chance. Number 7, In a game of chance, the probability of winning is 30. So there's your success. So therefore, the probability of losing is 70. It's their complements. If 15 games are played, find the probability of winning exactly 6 games. So that'd be combinations. Out of the 15, we're going to win 6 times. The success, and you could do this as 0.30. Just make sure that you don't do it as the 30%. Make sure you change it to either fraction or decimal form. So you could do either 0.30 or you could do 3/10. And we're going to win 6 times, and we're going to lose. So 70% chance of that happening 9 times. So I would say that that's going to be more likely than not. So a 30% chance of winning, 70% chance of losing. Type it into our calculators. And we get about a 19.08% chance of this happening. Number 8. A certain traffic light is red for 20 seconds, yellow for 4 seconds, and green for 36 seconds. Find the probability that of the next 12 cars that randomly arrive at the light, exactly 4 will be stopped by a red light. So that's going to be our success is the red light. So exactly 4 is going to be stopped. So out of the 12, so the combinations of out of 12, we choose 4 to get stopped, and that's going to be our success there. The probability of success is going to be a little bit different here. So a success is we can base it on how long the traffic light is red for 20 seconds out of it's yellow for 4 and it's green for 36. So 20 out of, if you add all those together, that's 20 out of 60 seconds is when it's red. So that's a 1 in 3 chance it's going to be red. So that means there's a 2 in 3 chance, or the other 40 out of 60 seconds. You can add those together. The other 40 out of 60 seconds, it's not red. So again, success, failure. What's the probability that we have 4 successes? That means that red light 4 times, green light or yellow light 8 times. We multiply we multiply all those 3 things together, and we get about a 23.84% chance of exactly 4 cars being stopped. Number 9. Now these are a little bit different because I want to point out that on these, instead of exactly, it's going to be okay, Kyle tosses a coin 10 times. What's the probability that he will get tails at least 8 times? So this is going to require a little bit more work because if he gets tails at least 8 times, that could be 8 times, 9 times, or 10 times. So we're going to have 3 different problems to work out here. So let's start out with what's the probability? Okay, at least 8 times. That could be, like I said, he could get tails 8 times, he could get tails 9 times, or he could get tails 10 times, any of the 3. So let's start out, what's the probability that he gets tails exactly 8 times? That'd be the combinations of out of the 10 that he gets 8 tails. The successes would be, probability of success is 1/2. We're going to raise that to, we want to do that 8 times. And then the failures would be 1/2, and we want to do that 2 times. Now I'm going to go ahead and write down the other ones. To get a tail 9 times, that'd be the combinations of out of the 10, we choose 9 for tails. So we're going to get a success 9 times, and then we're going to get a failure the other 1 time. Or the probability that we're going to get tails only once would be the combinations of 10, choose 10. Let's see, of getting it all 10 times would be the combinations of 10, choose 10. So we have all 10, and that's not going to be likely. All 10 are going to be 1/2, and then this failures would be no times. And then we calculate those percentages, and I'm going to just write these down. And here's what I got. The combinations of 10 choose 8 times 1/2 to the 8th power times 1/2 to the 2nd power gives me and that's a 4 right there, 0.0439. I've not changed it to percent, so that's about a 4% chance of that happening, 4.39. The other 2 are less than 1% chance. It's not very likely that if you flip, and it makes sense that if you flip a coin 10 times, that you're going to get even 8 heads. There's only a 4% chance of that happening, but to get 9 heads or 10 heads, the probability of getting 10 heads, or excuse me, was it 10 tails out of the 10 flips is 0.1%. So one tenth of a percent, so not likely at all. So what's the probability of getting any of these, 8, 9, or 10? All we have to do now is add those three things together. And when you add them together, you get 0.0547, which would be a 5.47% chance of getting an 8, 9, or 10. Number 10, Carol randomly chooses a day of the week 6 times. What is the probability of choosing Tuesday or Thursday at most 3 times? So at most means choosing Tuesday or Thursday no times, 1 time, 2 times, or at most 3 times. Okay, not more than that, but at most. So she randomly chooses a day of the week 6 times. What is the probability of choosing a Tuesday or a Thursday? So that'd be our success. Our success is Tuesday or Thursday. So let me come over here. The probability then of success would be a 2 in 7 chance that she's going to choose a Tuesday or Thursday. So therefore, a failure would be her choosing anything else, which would be a 5 in 7 chance of her choosing something that's not a Tuesday or Thursday. So we start with 0, so that'd be the combinations. She's choosing 6 times, so 6 choose 0. So that's how many ways we can have a success? None. So that'd be a success would be 2/7, so we're going to have that happen no times, and then 5/7 would be the other 6 times. Let me draw me a line down through here. What about choosing it 1 time? That's going to be the combinations of 6 choose 1. So that's what is the probability of having 1 success? So that'd be 2/7 to the first power and 5/7 to the other 5 times. Having a success twice would be the combinations of 6 choose 2. So we're going to have 2 successes and we're going to have the other 4 failures. And then the combinations of 6 choose 3 would be we're going to have 3 successes and we're going to have 3 failures. And I'm going to again pause and write down those combinations after I get them calculated. And here's the different probabilities I got. About a 13% chance that you're not going to choose either Tuesday or Thursday any. About a 32% chance, and notice these two are actually the exact same things. About a 32% chance that you're going to choose a Tuesday or Thursday at least once or twice, or you're going to choose it once or twice. And then there's a 17% chance that you're going to choose Tuesday or Thursday 3 times. And we just simply, to find out what's the probability of 0 through 3, we add all those probabilities together. And you're going to get 0.9402. So there's going to be about a 94% chance. So that's very likely that that's going to happen, that if we, again, randomly choose a day of the week, and we do that 6 times, what's the probability of choosing at most 3 times? There's going to be a 94% chance that we only choose it 0, 1, 2, or 3 times. Okay. Number 11. Got 2 more problems. The soda company prints prizes inside their bottle caps. The probability of winning a prize is 1 in 3. So that's going to be our successes. Out of the 8 bottle caps, what is the probability that at least 5 are winners? So that means that at least 5. So that means we might could have 5 winners, 6 winners, 7 winners, or 8 winners, because we're choosing out of the 8 bottle caps. So the probability of success, again, success is a 1 in 3 chance of success. So therefore failure, 2 out of the other 3 are going to fail. So the probability that you get 5 would be the combinations of out of the 8, we're going to choose 5. The probability of success, we want 1/3. We want that to happen 5 times, and we want the losers to be 3 times. The probability it's going to happen 6 times would be combinations of 8 choose 6. We want 6 winners and the other 2 losers. Combinations of 8 choose 7 is how many times it could happen that we could have 7 winners. So we have 7 winners and 1 loser. And then finally, the combinations of 8 choose 8, and that's actually going to be 1. There's only one way that all 8 could win, and that's if everybody wins. So we have 8 winners, and we have no losers, and I can already tell you that one's not going to be very likely. If there's only a 1 in 3 chance that you get a winner, the probability that all 8 are going to win is not going to be very likely. And there you see all the different probabilities. And really, none of them are very likely. That if you only have a 1 in 3 chance, the probability of getting 5 winners out of the 8 is only a 6% chance, nearly 7. The probability of getting 6 winners is going to be nearly a 2% chance. And then the probability of getting 7 winners or 8 winners out of the 8 are less than a 1% chance. When we add all those probabilities together, that would give us the probability of getting at least 5, which could be 5, 6, 7, or 8 winners. And that's going to be 0.0880, which is going to be an 8.8% chance that you're going to have at least 5 winners. Now, something else we could look at, well, what's the probability that we're going to have less than 5 winners? You could use complementary events there. The probability that you're going to have less than 5 winners would be the other 91.2% chance. Okay, so more than likely, you're going to have less than 5 winners. Okay, and the last problem says there are 7 boys and 5 girls on a debate team. Each week, one is chosen at random to lead the debate. For the next 10 weeks, what is the probability no more than 4 girls will be chosen to lead? Since we're doing no more than 4 girls, that could be 0 girls, 1 girl, 2 girl, 3 girls, or 4 girls. And that's for the next 10 weeks. So that's our different probabilities we're going to have to calculate. So the first one, let's talk about successes and failures. That's something good to start with. The probability of success, again, we want to know the probability that girls are chosen. So there are 5 girls out of, there's 12 students. So probability of choosing a girl would be a 5 in 12 chance. So a 7 in 12 chance of not choosing a girl. And again, that's what makes this a binomial experiment, is because those two add up to a whole. So therefore, the chances of choosing no girls, so we're picking for 10 weeks. So the combinations of 10 choose 0. We're choosing no. We have no successes here. That'd be 5/12 to the no power. And we know that goes away anyway, but it's still good to get into a habit. So that'd be 7/12. So that'd be 10 failures, no successes, and 10 failures. 10 choose 1 would be 1 success and 9 failures. Combinations of 10 choose 2 would be 2 successes and 8 failures. Combinations of 10 choose 3, that means 3 successes, and that would leave you with 7 failures. And finally, the combinations of 10 choose 4 gives you 4 successes, and I want the other 6 to be failures. And let's again pause, and I will calculate each of these. And there you see each of the different probabilities. The chances that no girls are chosen is less than 1% chance. That's going to be a 0.46 chance, nearly a 0.5%. Chances that one girl is chosen, and not very likely. There's probably going to be more than one. That's going to be about a 3.2%. And then you have a 10% chance that 2 are chosen, nearly a 20% chance that 3 are chosen, a 24%, nearly 25% chance that 4 are chosen. You add all those together, there's going to be about a 59.08% chance is the final answer. 59.08% chance that we're going to choose no more than 4 girls. So that's what's the chances of the complement of that, which would be choosing more than 4, would be about a 40% chance, which is also not very likely. About a 40% chance. More than likely, we're going to choose between 0 and 4 girls for this debate team.